Hello, today we have plotting graphs with Matplotlib. Matplotlib is one of the core tools in the data science toolkit because it helps at every stage of working with data. It is the most developed and widely used plotting package in Python. It generates graphics of your own data. You can also do exploratory data analysis. We'll see in the future what is this. Basically, you can explore the distributions of your data, of the different properties and variables, spot outliers, check relationships between variables and between the input variable and output variable even before you start modeling, and show your results. Communicate the findings with clear and well-formatted graphs, charts. So in short, it helps you explore, visualize, and communicate. We share 3 fundamental steps of any data science and machine learning project. If you haven't done so, you can go ahead and install Matplotlib. For example, here in PyCharm, you just go here, you write Matplotlib and you will install it. In this case, we already have installed it. In the terminal, you just open a terminal somewhere on your computer and you write this Python minus m pip install matplotlib. Sometimes it's just py. In Google Colab, it is already installed in Google Colab because it's part of the data science toolkit there. But if you need, because of some reason, you use this instruction in Colab also. Remember that in Colab the files are temporary and anything that you install results in the next runtime. So you have to install again. Let's go first for basic plots. First we need to import pyplot from matplotlib. Pyplot provides the functions to create and display plots. Okay, import like this. So import numpy also because we'll need functions to generate data and to handle data and arrays. So we also import numpy. Let's start right here. To practice, we do everything the same here. Okay. Okay, it's still charging. Okay. Okay, create an array of 100 evenly spaced values between 0 and 10. Okay. X, this is for the X variable. And we use this function to create 0, 10, and between 0, 10, 100 points. The graph, by the way, that we are going to create is this. It will have a title, it will have a label here, a label here. This is between 0 and 10, and this is the sign. Okay. And everything that we don't do here, it does by default. For example, this line and this blue line. So let's continue. Compute the sign of each value in X. NumPy applies the sign to every element in the array, in the X that you generated, and it applies the sign function and stores as y variable. To generate the plot, the y plot versus X, you call pyplot from matplotlib and you plot X and Y. Add a title to the plot. We again call pyplot and point. We add a title and we define the title. And then labels. We define labels with this instruction for X and this for Y. Display the plot. In the end, you always have to do this, okay, to show for the plot to appear. And then appears with all these instructions. Let's try right here. X line space 0, 10, 100, epsilon, np, scene. Okay, we have the x and y. Let's put this together. It is better. plt plot. We generate the plot. plt plot. Title. Basic plot. Let's keep it this way. Okay, let's show everything. It's ready. Okay, and we have the plot, the same basic plot. Let's continue for the next one. 5.2, specifying line style, marker and color. Within this, then we can format in different ways. Now we will have, besides the sign, we'll have the cosine plot, okay? And we'll have the labels at the bottom, and I think that's pretty much it. And we have different shapes here, different kinds of lines. Let's see how we do this. So, for this instruction, what does this mean? What we have here new, it's this instruction, which means the R means the red color, and these two dashes means a dashed line. Okay, when you put it like this, it will generate with red color and dashed line. For the cosine graph, part of the graph, we wanted a blue dotted line, and so for blue we have B, blue color, and for the dots we have these 2 points. Everything else, it's taking the epsilon that we had and generate it as the cosine of x. And we label it as cosine. Now we label it inside the plot, okay? Then we can just use legend instruction for the labels to appear. They usually appear right here, but then you can also orient and then show the plot. So let's go for this plot. Also try here. X epsilon R 2 dashes label. Let's label it sign. Exactly. We can do it together. Plot. Another one. X and P point cos of X. B with dots, dotted line, and label. The label can be this one. I think is everything okay? Let's just confirm. It seems. So we add the legend here. And we show the plot. And it should appear. And that's right. Now we change it to this right here, but you can define where it goes, okay? With instructions. So let's imagine you have experimental results and you want to define error bars, or even you have the error of your predictions also, for example, from a Gaussian process. And let's define this error. This error is defined by this instruction, okay? And this is the amount of the error. The amount, let's define first the error for the epsilon values. The error will be set to 10% of the absolute value of sin x. So to define this value here to this variable, we multiply by 0.1 the absolute value of the sine of x, and we use the numpy library. Then we will plot epsilon versus x with the vertical error bars, these things right here. We share 10% of the value of x. This will be the instruction for the error values of the epsilon axis. Okay, this is the instruction. This is the values. This here, okay, it plots data points as circles now. Okay, now we have circles here. The color of the error bars, color of error bars, so e-color gives the color of error bars, and we define the standard, which is usually gray. Cap size. What is this cap size? Size of the small horizontal caps on the error bars. What does this mean? We have defined these values, okay, 10%, and now these caps, the three, are defined. These horizontal lines on the top and bottom, okay? And 3 is quite nice. PLT title, now the title of the plot with error bars, and then we show it. So let's try right here, and let's change the cap size, not forget, for us to see what it is. We want the absolute value. We again use the numpy library and the sign. Okay, that's nice. PLT, let's define the error bar. Exactly. It can be like this, okay. A color, let's give it gray. Give it gray. And cap size, let's put it 3. Okay, 5. Just to compare right away. And then we change. 5 can be already a little bit bigger. But also plot with error bar. No, we don't need this. We'll just show PLT. Let's check. Okay. We cannot compare, but you can see that this is a little bit higher, bigger. But let's compare. Let's put side by side here. And let's put 10. This is what I wanted. And 10, you see that it increases a lot. These horizontal lines. Okay, the vertical bars are already defined. If you wanted to increase let's 0.3 to be really big. Okay, it increases. So 0.1 and 3. This is the excellent value for it. Okay, error bars, there we go. So let's go to setting plot limits and excluding data. Basically, it is like doing a zoom of part of a plot, and let's see how it goes. For example, here we wanted to represent between 2 and 8, and between minus 0.5 and 0.5. And to do this, we generate a plot, epsilon versus x, set limits on the x-axis, only values between 2 and 8 will be shown, so we use the instruction xlim between 2 and 8. And the same for y, for the y-axis. We use values only between 0.5 and 0.5 will be shown, so we use the instruction for lim between minus 0.5 and 0.5, and then we show the plot. And we will have something like this. Let's first generate, let's now generate something like this. The limits, xlim, plt, between, but let's also do different for us to show that it works. And what does it change? So what we changed it was here. The y limit between, instead of being between minus 0.5 and 0.5, it's between minus 1 and 1. And we can see a larger part of the plot right here. So it's like zooming and just representing part of your data without having to change the data itself. So really nice, okay. Really clean. Okay, comparing, for example, with something from Excel, where we would have to do a lot of things just to change and represent. Subplots. Now, what are subplots? Basically, represent two plots on the same image, okay, side by side. And let's see what we want. Let's first create a figure with a specific size. This is like creating a table to insert the images, like in Word. And we define the width, okay, the width. And we define the height in inches here, okay, the height. And we create the first subplot. We say that we want to have, on this instruction, one row with two columns, okay? And then this one, this is the same, one row, two columns. This means that it is the first plot, and this one, it's the second plot. So then we plot and we give titles. Plot, just change from sine to cosine, and then we show the results. Okay. Subplot. Let's put it right here first. PLT figure. Let's define fig size. Okay. Let's keep the same because then it's already optimized. Subplot 1 row, 2 columns, first image of that first plot. PLT plot x y to represent PLT title. No, sine. Okay, the first one is defined. Let's go to the second one. Subplot one row, 2 columns, second plot. It will be PLT plot to represent. We want the x and we want for the y to be the cosine. And PLT title cosine, and then plt show the plot, and there you have it. The two plots, the sine, the cosine, side by side. Okay, let's change this if we wanted a third plot. It will just, I don't know if it works for such a small space, but leave space for the third one, which is not really optimized for this size, so let's keep it as it is. Exactly. But we can do something else. One, and let's do here if it works, just to try. Okay, so 2 rows, okay, 1 column. But it looks nice. Okay, I could do it right here. And let's leave it right here, right as it is. I show the difference between doing 1 row, 2 columns, okay, or 2 columns, 2 rows, 1 column. Nice. So this is the first part of plotting graphs with Matplotlib. We have 2 more and then probably some exercises. Okay, so thank you very much. Let's go for the next one. See you.